And hello all, welcome back. Lesson 10A, 4D, which is actually chapter 11, lesson 10 in the textbook. Measuring composite figures. What does that mean? More on that coming up. Pause your video, come on back after you checked your assignment. Pause again, come on back. All right, folks. Now maybe you've heard of a compound in science class. And recall that a compound is a material that's made up of two or more elements. For instance, water, H2O, is hydrogen and oxygen. Carbon dioxide, carbon and oxygen. Even ammonia. I can't remember if ammonia is NH3 or NH4. But the point is, it's made up of two or more elements. Now, in the same manner, composite figures are made up of two or more shapes. Maybe they're two-dimensional areas, maybe they're three-dimensional volumes. And that is our goal from here. Pause your video, whatever the date, whatever the assignment number, come on back when you're ready. All right, so I'm going to take you through some examples, and really today I would say is a challenge, but it's not as hard as you might think. See, we already know how to find areas, we already know how to find volumes. Your goal is to identify the sub-shapes and then determine if they should be added or subtracted. And here's what I mean. If I have a building, a barn, say, and I want to heat this whole barn, I need to find out how much volume is in everything, but I'm going to split it up. I'm going to split it up into a larger rectangular prism on the left, a smaller rectangular prism on the right, and then I'm going to say, look, do I need to add or subtract those volumes? Well, if I'm heating up the entire barn, that's kind of like a total question. What is the total volume? And so I'll add those up. Now, when you're doing this, you could either draw the subshapes, you could just write the words, you could even write it in abbreviated form. But that's all I'm going to do for the next minute or two. Just practice what shape or shapes that you see, and then decide when it will be added and when it might be subtracted. Let's take a look at this next one. If you are painting something on a basketball court, what shape or shapes do you see? Now, the large shape, of course, would be a rectangle. Small shape is not a circle, but it would be a half of a circle. And if we are, I notice the whole thing is gray. If we want to paint the entire thing, we are going to add those up. That's all I want to practice right now. We'll get to areas and volumes and actually find out later. Let's go ahead with this particular example. If all we want is the shaded region, the light blue space is going to be shaded. What shape or shapes, and should we add or subtract? Well, I always start with the big one. Naturally, the big one's a circle. But if I found that full circle, I have a square in the middle, and that square is not needed. That's not blue. In other words, we don't need paint for that region. So that, ladies and gents, is an example of when you would subtract, when one part is not needed. Let's go to this next one. Pause the video if you want. Think about it. Come on back when you're ready. So believe it or not, the bigger shape is actually the half circle. But I know even if you put either one, it'd be fine. Now, should we add or subtract? Everything looks shaded. We want paint for the whole area. Let's go ahead and add that together. Speaking of areas, those are 2 dimensions. Let's get the 3 dimensions. We got foam packaging right here. We want to find all the volume of the foam. So if I take a look at this bottom part, that looks like a prism, and it's in particular rectangular prism. Now I take a look at the top part, which really appears to be another rectangular prism. Now, if the entire thing is foam, we are naturally going to add them together. So again, you're going to identify what shape or shapes that you see, and then decide, do we need to add them together or subtract them? What is the particular problem asking for? If you want, pause, come on back when you're ready. I'm not surprised if you come to this conclusion very quickly. I see 2 cones, and if the entire thing is shaded in, we're going to go ahead and add the volumes of both of those cones. Now this one you see often as you're driving along the road. I suppose it's missing kind of an important piece. I'm just going to make this up, but you couldn't figure out any volume if you don't have the height. Meanwhile, that big shape is in fact a cylinder. The smaller shape is a cone. And if grain is dumped and then loaded up to the top, you can actually fit grain both in the bottom as well as the top. So, to find the total volume of that silo, you would add the volume of the cylinder together with the volume of the cone. Whoops, my bad. Now, this one tends to be a little trickier for some folks, so I want you to picture a pipe, all right? Let me go to some gray here. And perhaps not surprising to you, the pipe is going to be hollow. If it's going to have water or even air or whatever material is going to flow through it, you don't actually have anything in the middle. In fact, I'm going to put that X there. Now, what I'm seeing is a cylinder if we wanted to find the whole thing. But now I want you to envision what that middle piece looks like. So again, I see a circle, but that middle hollow section goes down the entire length of the tube. In fact, ladies and gents, it's another cylinder. And since we do not need plastic or metal for the inside of that pipe, you're going to actually subtract the little cylinder from the big one. Now that's important because if you flip it around, if you do little minus big, you're going to end up with a negative volume, which naturally does not make sense. How could you have a negative amount of plastic? It's not nonsensical. So that one tends to be pretty tough for some folks. Let's go on to the next one, shall we? This one also can be pretty tough for some folks. First piece is what appears to be a very large prism. In fact, it's a prism with a rectangular base. Come on, fella, you can do it. There she is. All right, now the top part is what gives people difficulties. It's got edges, so it can't be a cylinder, a sphere, or a cone. Okay, so what is this guy? Is it a prism or a pyramid? Oftentimes students guess pyramids, which is not correct. Just because you see one triangle doesn't mean that whole thing is a pyramid. In fact, it's actually a prism that's flipped over on its edge. Let me make this a little smaller so you can take a closer look. Remember that prisms are made up of not one, but two bases, and then they're surrounded by several rectangles. So the roof portion of this barn is a prism, and in fact, to be more specific, it is a triangular prism. Now, if you want to heat the entirety of the barn, you would, of course, add the volumes together because that's the way barns are oftentimes. There's no ceiling. You have to heat the whole thing. All right, let's take a look here. A ball is packaged inside of a cube box. The ball touches the walls of the box. Find the air surrounding the ball. In other words, what is this particular space? All right, what's the big shape? You might have said prism, but to be more specific, it is a cube. What's the small shape? Now be careful. This drawing is not a great drawing. It says it's a ball, ladies and gents, and that is 3 dimensions. So it should be a sphere. Now, if we are going to subtract the sphere, that would leave you with only the air that's around the ball. Maybe you want to fill it up with foam peanuts or something to protect it. I don't know. But the point is you have to get rid of the sphere because you don't need the volume of that sphere to fill up with foam peanuts. Now this is going a little backwards. So here I actually give you the formulas, and I want you to work backwards and try to identify what shape or shapes would you see. All right, Mr. Cowan, come on, length times width. We got a big old rectangle. But if we're subtracting, we do not want this circle. So you might have a shape that looks something like this. Maybe you want to paint the rectangle blue, but you do not need to paint the circle. So that's what it would look like, almost like a hollow part in the middle. All right, so what do we got right here for number 2? Now we're talking 3 dimensions. Pi radius squared height is a cylinder. 1/3 pi radius squared height, well, it's almost a cylinder, but because of that third, it's a cone. And if I look closely, I see that we're adding it up. Gee, we've kind of had something that looks like this, kind of like the silo problem. You have a cylinder, you have a cone, and you want the total volume, so it should be added. All right, let's get to some homework problems now. These are the best renditions I could come up with. Your book has much better pictures, in my opinion. Let's take a look at number 1 and numbers 4 together. Now, number 1, we clearly are trying to paint an area orange. We have a circle as the big shape, a square in the middle, and since we do not want the square, we're going to go ahead and subtract. All right, that's the first step. Let's go ahead now. I'm going to myself write pi times radius squared. Now, I know some of you are dying to put length times width, and I suppose that'd be okay, but folks, it's a square. How about side times side, or side to the second power? And naturally, we're going to go ahead and we're going to subtract those since we don't want the square. From here, I'm going to start writing and filling in the dimensions. So let's take a look at our circle first. I look carefully at the 10 and I say, is that 10 a radius or a diameter? Well, in this particular case, the 10 starts in the middle, goes to the outside. That is a radius. Meanwhile, for the square, it appears to have side lengths of 4. So we have pi times 10 squared minus 4 times 4. And if we type that in, you go ahead and let the calculator take care of the rest. You're going to get something like 298.1592 dot dot dot, but look at that 15, and that 9 puts it closer to, which is at 15 or 16. That'll be closer to 1600ths. The last thing I do is I ask myself, what am I measuring? Is this inches, square inches, or cubic inches? Well, it's an area. After all, I want to find out if I were painting this, how many squares of paint would I need? Thus, square inches. Now, as we go into number 4, I want you to look for similarities. I want you to look for differences. Similarities, the first thing we look at is for individual shapes and then decide to add or subtract. A difference, though, this is 3 dimensions. So, for instance, that big shape is going to be a cylinder. Small shape is going to be a prism. If you want to be more specific, I would note that it is a, well, I almost said rectangular, but technically you could be more specific and call it a square prism. Anyways, not the best version, but if you look in the book, you're going to see that, again, it is empty. We're going to take it away. I'm sorry I didn't give you an add problem, but there will be other add problems here. Next up, let's go ahead and write the formulas, pi radius squared height. And here I will actually use length times width times height, although you could use side times height. All right, now we go ahead and we take a closer look and we substitute in our dimensions. For the cylinder, I notice that 10 appears to be a radius, so pi times 10 times another 10, and the height is 15. For the prism, I look up at the top or the bottom, and I notice that's going to be 4 by 4. Wait a second, what's this height? Well, the height is the exact same height as the height of the cylinder. If the height of the exterior of the cylinder is 15, then the height of that interior prism is also 15. Go ahead and multiply all those out. You'll get 4,552.2, I believe that was a 3889, blah, 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 blah. But if I go to the nearest hundredth, is that closer to 38 or 39? That's definitely closer to 39. And once again, I ask myself, what am I measuring? Well, in this case, it is a 3-dimensional volume. In other words, how many cubes would it take stacked up to fill that space, not including the middle portion? Now, may I point out that the first several problems on the homework already have drawn pictures. On the flip side, you might choose to draw your own pictures as you get toward the end. I would suggest it doesn't have to be a beautiful drawing. It just has to be something that would help you. Folks, that's what I got for you. No matter what the date, no matter what the assignment number, hit up page 327, 1 through 10. Do well. Let me know if you have any questions. See you.